Hello everybody, I'm Muhammad Atwa and I'm here today to talk to you about our DSD project. I have 4 colleagues, Muhammad Halawa, Muhammad Omar, Muhammad Amr and Amr Abu Greda. Our project name is the Future Fan. We actually thought about enhancing the current type of fans to make it more suitable for future. We triggered 3 main points. The first point is to automatically initiate the fan. So we installed a temperature sensor that will read and keep track of the temperature in the room, and when the temperature comes below a certain level of temperature, it automatically initiates the fan. At that certain level, the user specifies. And that brings us to safety. What if the fan is initiated and it's turned on, starts swinging, and some kid played with it with his finger, or maybe an object moved in that fan and didn't know that it's on. So we thought about installing a motion sensor that stops the fan immediately if any object moved in the front of the fan. And combined with that motion sensor, we installed an alarm sensor. So when it stops the fan, it turns on the alarm and the user be aware that there is something wrong is happening and some object tried to work or play or mess with his fan. And now my colleagues will describe the components.
And now, with our main components, with Muhammad Amr,
and Halawa.
we have to think about what are the main components for the product. Ultrasonic sensor, the fan, the Altera board, the breadboard, the sound alarm sensor, the temperature sensor, the H bridge, and the battery. For more info about the H bridge, here is Muhammad Halawa.
I'm Muhammad Halawa, and we will talk about edge bridge. Edge bridge consists of motor A, which is connected to the fan, and motor B, which is connected to the sound alarm, and the blue pins connected to the battery. The blue wire is the ground, and the green wire is the VCC, and it's also connected to the board, to the VCC 5 volt, and to the ground, the yellow wire.
And now, with the rest of our main components, after finishing that bridge with Muhammad Halawa, we're gonna go to the breadboard with Tira. Our main component is the breadboard, because it's the main thing that we use in order to combine all of these components with each other. We had to take all the VCCs and the ground from each component, connecting them on a straight line, CS with each other, connected to the Altera, and connected to the H bridge, from where we get our power supply from the battery, in order for the fan to move, in order for the sensors to work and to function. We had pin number 11 and 12. The 11 was the ground, 12 was the VCC. Connected to the breadboard, connected to all of them in order to function.
And now, after my colleague explains the H bridge and the battery and how it supplies the 5 volt VCC to the breadboard and the ground, that brings us to the temperature sensor. The temperature sensor takes the 5 volt VCC through this blue wire from the breadboard, and the ground is connected with the red wire to the breadboard, and this wire, green yellow, it's extension from the sensor to the Altera port to pin 40 for pin assigning and the header expansion. And actually we took how to assign that wire and how to assign that pin in the Altera from an internet reference. And I'll take you to a small simulation about how the project works. As I said earlier, the temperature sensor is responsible for how to initiate the fan, and we made the temperature level nearly 35 degrees, and to make that fan turn on, we have to heat the room. That's by doing some heat here in the sensor, and we see the temperature sensor The temperature sensor reads temperature and initiates the fan. And for the motion sensor, my colleague Amr Abu Greda will talk to you about it.
Hello, this is Amr Abu Greda. Now I'm going to talk about the ultrasonic sensor which is responsible for stopping the fan for the safety of the user. The ultrasonic sensor have 5 pins. We are using only 3, which is the DO, VCC and the ground. The VCC and the ground are linked to the breadboard. The VCC here is connected to the VCC section and the ground here is connected to the ground section. The DO, which is responsible for giving information to the Altera, is connected to pin 39 expansion header, which stops the fan if someone is in front of the fan. The fan here stops when there is anything in front of it, and then it moves again. And this blue light here flashes, is turned off, so the fan stops, and again it's on.
Hello, I'm Muhammad Omar. After we have discussed our inputs, we'll be talking about the outputs. First, I'll be talking about one of our outputs, which is the sound buzzer. The sound buzzer is connected to motor 1 over here in the edge bridge, and it's enabled by the brown wire over here. It actually takes its voltage from the battery, which is also connected to the edge bridge. The green wire is connected to the brown wire in a series way, and then the green wire is connected to the expansion header in pin 7, and this all works by our Verilog code. Our Verilog code states that the sound alarm is equal to assigning both the temperature and the ultrasonic sensor. So when our temperature is equal to 1 and our ultrasonic temperature equal to 1, the sound alarm as a result will be equal to 1. Let's see how it works on the ultrasonic sensor. When I put my hand here, the ultrasonic sensor is going to turn into 1, and that's why the sound happens. When I remove my hand in any other case, it will be equal to 0, and that's why the sound stops.